Assalamualaikum warahmatullahi wabarakatuh. So today we are going to present about addition polymerization in the production of polyethylene. First and foremost, the definition of addition polymerization is the process where unsaturated monomers join together to form a polymer without byproducts. So one of the common usage in our daily relevance is plastic bottles, plastic containers, and also plastic packaging. So why this addition of polymerization is important? It is important because it is widely used, low cost, and also durable. Other than that, essential in packaging, construction, and healthcare. Lastly, it's one of the key examples in polymer chemistry. Addition of polymerization is known to be found in 1933 by Imperial Chemical Industries used in World War II for cable insulation. One of its contribution is supports industries and economy, advances polymer industry, and lastly raises awareness of plastic waste recycling.
I will be explaining the key chemistry concepts, specifically in addition polymerization of polyethylene. So addition polymerization involves monomers like ethene, which has a carbon-carbon double bond. A carbon-carbon double bond is a type of bond which is reactive and can be broken down to form a long polymer chain, or also known as a long chain of repeating units. So the general equation can be written as many monomers, which is ethene, joining together to form polyethylene, which is its polymer, without any subunits forming or any small molecules. Next, I have written on my slide about the polymerization mechanism, which has 3 steps, which firstly is initiation. So during initiation, there will be a free radical forming to start the reaction. Secondly, we have its propagation, which is when monomers continuously add to the growing chain. Lastly is termination, where reactive ends will combine and stop the reaction. I have also written about UHMWPE in my slide. UHMWPE also uses the same mechanism, except it uses a catalyst which is known as Ziegler-Natta catalyst. So the catalyst helps to support the structure as well as to control the reaction, making it a long chain of polymer, but using a higher reactive order, which gives it special characteristics like high durability and high strength. Overall, this process is important for our everyday usage, especially in making materials, for instance, like HDPE and other polyethylene materials, to help with our everyday needs.
Polyethylene is widely applied in the world, such as ultra-high molecular weight polyethylene, an example that mentioned by Safia just now. It is a polyethylene produced through addition polymerization with a Ziegler-Natta catalyst, and it involves over 100,000 over monomers in a single chain. So first, in the medical field, it is used to create artificial joints. Due to the chain entanglement of these long molecules, the material has high mechanical strength, which is strong enough to withstand human body weight and last long. Moving on to industry, we use it for conveyor belt. Since this polyethylene is hydrocarbon, it is non-polar and chemically inert. This means that when it comes in contact with food, it won't contaminate it and won't react with the food, so the food we consume is safe. Besides, we also see it in our daily life. For example, fishing lines are made from these polyethylene fibers. Because the long chains are highly aligned and crystalline, the fiber has zero stretch and very strong, so this makes it very suitable for fishing. So now I'll pass it over to Najmi.
First, the advantages. UHMWPE have a low friction coefficient, which means it's very smooth and reducible. It also has high impact strength, so it is very tough and durable. In addition, it's resistant to chemicals and corrosion, making it suitable for harsh environments. Next, the disadvantages. UHMWPE is expensive, which can limit its use. is also difficult to process during manufacturing. Furthermore, it is non-biodegradable, which creates environmental concerns. Now, the impact in health. UHMWPE improve mobility and quality of life, especially in joint replacement in society. It supports modern healthcare and advanced treatments. For the environment, it lasts a long time, reducing replacement, but disposal is still a problem. Finally, future trends. This include closed-loop recycling system, advanced medical technology, and the use of nanotechnology and smart materials.
In summary, addition polymerization is a process where small ethene monomers join together to form polyethylene. When the polymer chains become extremely long, it forms ultra-high molecular weight polyethylene or UHMWPE. These ultra-long chains give the material important properties such as high strength, low friction, and excellent wear resistance. Because of these properties, UHMWPE is widely used in various applications, especially in medical fields such as artificial joints, implant, and prosthetic. For instance, strong intermolecular forces in artificial joints don't break easily. High resistance and strength making fishing line does not break easily, and low friction making joints move smoothly. Therefore, this shows how a basic chemistry concept like addition polymerization can lead to advanced materials that improve healthcare and enhance the quality of life. That's all from us. Thank you.